In January 1986, tens of millions of people tuned in to watch the launch of the Challenger space shuttle. Approximately 73 seconds after liftoff, the shuttle exploded, resulting in the deaths of everyone on board. Though tragic enough on its own, one of its crew members was a schoolteacher named Sharon Krista McAuliffe. McAuliffe was selected from over 10,000 applicants for the NASA Teacher in Space project and was scheduled to become the first teacher to fly in space. As a result, millions of those watching were schoolchildren. NASA had the best scientists and engineers in the world, and if there was ever a mission NASA didn't want to go wrong, it was this one. The Challenger disaster, alongside other catastrophes, serves as a chilling reminder that even with the best expertise and intentions, accidents can still occur. As we progress in developing advanced AI systems, it is crucial to remember that these systems are not immune to catastrophic accidents. An essential factor in preventing accidents and maintaining low levels of risk lies in the organizations responsible for these technologies. In this section, we discuss how organizational safety plays a critical role in the safety of AI systems. First, we discuss how even without competitive pressures or malicious actors, accidents can happen. In fact, they are inevitable. We then discuss how improving organizational factors can reduce the likelihood of AI catastrophes. Catastrophes occur even when competitive pressures are low. Even in the absence of competitive pressures or malicious actors, factors like human error or unforeseen circumstances can still bring about catastrophe. The Challenger disaster illustrates that organizational negligence can lead to loss of life, even when there is no urgent need to compete or outperform rivals. By January 1986, the space race between the US and USSR had largely diminished, yet the tragic event still happened due to errors in judgment and insufficient safety precautions. Similarly, the Chernobyl nuclear disaster in April 1986 highlights how catastrophic accidents can occur in the absence of external pressures. As a state-run project without the pressures of international competition, the disaster happened when a safety test involving the reactor's cooling system was mishandled by an inadequately prepared night shift crew. This led to an unstable reactor core, causing explosions and the release of radioactive particles that contaminated large swathes of Europe. 7 years earlier, America came close to experiencing its own Chernobyl when, in March 1979, a partial meltdown occurred at the 3 Mile Island nuclear power plant. Though less catastrophic than Chernobyl, both events highlight how even with extensive safety measures in place and few outside influences, catastrophic accidents can still occur. Another example of a costly lesson on organizational safety came just 1 month after the accident at 3 Mile Island. In April 1979, spores of Bacillus anthracis, or simply anthrax, as it is commonly known, were accidentally released from a Soviet military research facility in the city of Sverdlovsk. This led to an outbreak of anthrax that resulted in at least 66 confirmed deaths. Investigations into the incident revealed that the cause of the release was a procedural failure and poor maintenance of the facility's biosecurity systems, despite being operated by the state and not subjected to significant competitive pressures. The unsettling reality is that AI is far less understood, and AI industry standards are far less stringent than nuclear technology and rocketry. Nuclear reactors are based on solid, well-established, and well-understood theoretical principles. The engineering behind them is informed by that theory, and components are stress-tested to the extreme. Nonetheless, nuclear accidents still happen. In contrast, AI lacks a comprehensive theoretical understanding, and its inner workings remain a mystery even to those who create it. This presents an added challenge of controlling and ensuring the safety of a technology that we do not yet fully comprehend. AI accidents could be catastrophic. Accidents in AI development could have devastating consequences. For example, imagine an organization unintentionally introduces a critical bug in an AI system designed to accomplish a specific task, such as helping a company improve its services. This bug could drastically alter the AI's behavior, leading to unintended and harmful outcomes. One historical example of such a case occurred when researchers at OpenAI were attempting to train an AI system to generate helpful, uplifting responses. During a code cleanup, the researchers mistakenly flipped the sign of the reward used to train the AI. As a result, instead of generating helpful content, the AI began producing hate-filled and sexually explicit text overnight without being halted. Accidents could also involve the unintentional release of a dangerous, weaponized, or lethal AI item. Since AIs can be easily duplicated with a simple copy-paste, a leak or hack could quickly spread the AI system beyond the original developer's control. Once the AI system becomes publicly available, it would be nearly impossible to put the genie back in the bottle. Gain-of-function research could potentially lead to accidents by pushing the boundaries of an AI system's destructive capabilities. In these situations, researchers might intentionally train an AI system to be harmful or dangerous in order to understand its limitations and assess possible risks. While this can lead to useful insights into the risks posed by a given AI system, future gain-of-function research on advanced AIs might uncover capabilities significantly worse than anticipated, creating a serious threat that is challenging to mitigate or control. As with viral gain-of-function research, pursuing AI gain-of-function research may only be prudent when conducted with strict safety procedures, oversight, and a commitment to responsible information sharing. These examples illustrate how AI accidents could be catastrophic and emphasize the crucial role that organizations developing these systems play in preventing such accidents.